Find the derivative of y equals the square root of 2x plus 1 divided by x plus 2, then evaluate y prime of 4. So y here is the quotient of two different functions. We have in the numerator a square root of 2x plus 1, and then in the denominator an x plus 2. Let's rewrite that numerator expression with a fractional exponent due to the root, first power, second root, 1/2 power overall, over the x plus 2, so we can take the derivative. Now overall we have the quotient of the two functions, so it will be a quotient rule for our derivative, y prime or dy dx. The derivative of the numerator, it's a power rule, bring the power down, subtract 1 from it, I will call that 2/2, times the derivative of the inside to complete the chain rule, that'll be a 2, times the denominator left alone, minus the numerator left alone, times the derivative of the denominator, which is a 1, and then that entire thing is over the denominator squared. Now, everything's multiplied, and the constants can be put together, so we'll have that 2 times that 1/2, which is 2/2, which will cancel to be a 1. We also have a 2x plus 1 to the 1 minus 2, which is negative 1/2, and we have an x plus 2. And then we have minus, and then the second thing is all multiplied by 1, which just means it is equal to itself. So we have the 2x plus 1 to the positive 1/2. And then all of this is over that denominator squared, so we have x plus 2 quantity squared. The 2 over 2, those will cancel to be just a 1. So y prime, or dy dx, is equal to, now this first term has a negative exponential. That will move to the denominator, this will not. So it will end up below it. So we have an x plus 2 over a 2x plus 1, which will now be to the positive 1/2 power. And we have minus a 2x plus 1, which is already to the positive 1/2 power. And the entire thing over x plus 2 quantity squared. The next thing to do is to get a common denominator between those terms in the numerator. There is a fraction, so we need a common denominator. And we have a denominator of 2x plus 1 to the 1/2 for this first fraction. That second one doesn't have a denominator yet, so we're going to multiply it by 2x plus 1 to the 1/2 over itself, a form of 1, so that we can get the common denominator. Now, what that will give us is the first fraction has a numerator of x plus 2. The second fraction has a numerator that will be these two things multiplying each other, same base, so we can add the exponents. 1/2 plus 1/2 is first power. Now it's being subtracted, so be sure to still put it in parentheses, because overall we have a minus sign between the fractions, and you subtract that entire numerator. These are now over the common denominator of 2x plus 1 to the 1/2. And then that entire thing is divided by an x plus 2 squared. So back here in the numerator, we can distribute the negative sign into that expression. We'll have an x plus a 2 minus a 2x minus a 1 all over 2x plus 1 to the 1/2. Another way to write that is square root of 2x plus 1 to the first power. So we can just write it that way now. And then all this is over x plus 2 squared. Now if we combine like terms in this numerator, we have a positive 2 and a negative 1. So that'll be a 1. And we have a positive x and a negative 2x, and that's a negative x overall. That's over that square root of 2x plus 1, and then all over x plus 2 squared. Now, since we have a fraction in the numerator, we're going to want to reciprocate the denominator and multiply with the numerator. Let's make the denominator a fraction by putting it over 1. So now our y prime, or our dy dx, is equal to 1 minus x over the square root of 2x plus 1 multiplied with the reciprocal, so 1 over x plus 2 squared. Multiplying the numerators, anything times 1 is itself, so that'll be just 1 minus x. And then multiplying the denominators, let's write the x plus 2 squared first, and then the square root of 2x plus 1 second. But the order doesn't matter. They're multiplying each other, so either order would have worked down there. And there's our simplified version of the derivative. The next thing to do is evaluate y prime of 4. So y prime of 4 means to plug a 4 in for each of the x's. So we will have 1 minus 4 divided by 4 plus 2 quantity squared times the square root of 2 times 4 plus 1. Now in the numerator, 1 minus 4 is a negative 3. In the denominator, 4 plus 2 is 6 squared. And then we have the square root of 2 times 4, which is an 8 plus a 1. So we have negative 3 over 36 times the square root of 8 plus 1, which is a 9. And so we have negative 3 over 36 times a 3. Now instead of multiplying 36 and 3, let's just cancel the 3's here and here, leaving a 1 in the numerator with that negative. So overall I'm ending up with negative 1 over 36.